Mm-hmm. Mm-hmm. Okay, so we're on YouTube now, and as always with YouTube, I'm assuming that some people are watching it either live or after the fact. And if you are watching it live, it's possible you haven't started from the very beginning. So I will just make some just so those of you who are watching now are aware and aren't annoyed by me saying this repeatedly. But throughout the stream, I will ask people to start watching from the beginning of the video, because I assume that we'll probably have some important questions answered at this time. So the first question was about getting an extension, and I actually cut you off. Would you mind repeating your question? Or maybe I answered it. I'm not showing up on YouTube. Oh, what? Really? Am I still not on YouTube? That's weird. I am? Okay. Yeah, okay. Yeah, I'm pretty sure I'm on YouTube right now. Like I can see the stream, so... yes, this is grade 11. Oh, shoot. That's what it was. I forgot to change the title. Oops. Grade Gr11 PreCalc. Okay. Yeah, sorry. It says grade 11. It should... Oh, what is going on here? Grade 11 PreCalc. Yeah, it should say grade 11 PreCalc now. I edited it. But I cannot begin to tell you the computer problems I've been having today. Like, it's insane. Like, it's kind of a big day because there's a change in the final exam process. So I've kind of been scrambling to inform everyone as soon as I possibly can. And on top of that, Windows has decided to stop working almost completely. Let me show you what I'm talking about. I'm sorry. I know that you got a lot of things on your mind right now. Okay, everyone's favorite button. The start button. Look what happens when I click it. That's not good. Like you can see in my oops, should not oopsies. Did not want to show you that. But yeah, I mean you can see in like I'm clicking. What the? I mean, do you see what I'm like? What is going on here? My computer is just. I'm finished with Windows. I'm just finished with it. Yeah, it's just, and here, yeah, it's so, ooh, someone on Discord thinks Windows is finished with me. And you know what, I totally agree. Yeah, I mean, I have been putting my computer through quite a bit of strain. I mean, live streaming is quite resource intensive. I have a very, respectable CPU, and here I'll show you my 60%, 60 to 70% is OBS Studio. Like that's a lot, and that's like that. I've got a fairly fast processor, and it's still, it's really, yeah. See, 89. Like this is what I'm at like all day, like 80, 90. I have 4 gigahertz, 8 cores. Like you'd think that my CPU would have no problem with this, but nope. This is what my CPU has to deal with all day. So I get it that it's done with me, but Windows is not my CPU. Like my CPU should be the thing that's crapping out, not the operating system. And I won't get started because it'll take me 10 minutes to tell you all the problems that I've faced today in terms of computer stuff. But anyways, so there was a question about the final exam. Did you want to repeat your question to me? Because I did actually cut you off before you finished. Can you repeat your question, and then I'll repeat it to the live stream. Okay, so if you'd like to request for an extension, that's a good question. I mean, I guess I was planning on. Yeah, I was planning on just having it like an email. So let's just say you have to email me by June 1st before midnight on June 1st. So like before 11:59 on June 1st. And yeah, so that's what we'll do. Also, please keep in mind that an extension request should include a reason for the extension. So I there's going to be a lot of projects for me to mark now, and projects will take quite a bit longer to mark than an exam. So there's no way that I can have these things marked by the 17th if I get them on that Monday. So I cannot have half the class requesting an extension. It just won't work. So and that's just like, that's not because I'm mean or that I don't want you to be successful in this. It's not. It's quite the opposite. There's just literally not enough hours in the day. Like I promise you, I will be marking from the moment I get these until report cards are done. Like there won't be any time in between. So so basically we have 3 weeks to do this instead of what we thought before was 3 weeks and a couple of days. So I've only increased the due date from a Monday to the Friday before. So it's actually only 3 days. It's only a 3-day difference. So it's not that big of a change, but it is, changing a final due date is kind of a big deal. But I think that the bigger change is that if you were planning on doing the exam, I'm afraid we can't do that, and I sincerely apologize about that, about sort of maybe misleading you in any way. That was not my intention. I'm not trying to mess around with anybody. That's just how it is. We're just not doing an exam. So I understand that some of you were looking forward to that, and for that I apologize. So I'm sorry that you can't do the final exam. But I still think that the project is a really cool thing, and I think it can be really fun, and it will allow you a really good opportunity to explore the topics that we've been learning in a really deep way. So yeah, there's some good and some bad that comes out of it, but yeah, so we will not be doing a final exam. And as just to repeat for the requests do need to be in before June 1st at 11:59. So sometime on June 1st, that's the last day that you have to decide if you need an extension, and the extension would only be for 3 days. So it would just be that for that one weekend. So yeah, that's how it's gonna go down. Yes, absolutely. So if you do have any other questions about any of this, please let me know. But I also do just ask for some understanding that we're all kind of trying to work together on this, and that I'm really just trying to do what's best for our class and within the confines of what we're allowed to do. So yeah, we're all doing our best here. Think about that extension if you need it. Like now would be a good time to think about if you need that extension. I mean, things that I would consider legitimate reasons for an extension is if you have a lot of projects due at that time or something like that, and because then I would ask for you to tell me which projects you have on which days, and maybe just ask why it has to be my project or the math project that has to be pushed back and not another project, right? So just some things to keep in mind. Let's all try to work together on this one. I think it'll be good though. If you were planning on doing the final exam, I think that there's a lot of good opportunity in the project. So if you were planning on doing the final exam and you're maybe a little bit confused about the expectations for the project, don't hesitate to reach out and ask for some guidance with the project. I'd love to help you out and get you started. I think what I've been telling everyone is to start with a topic map. So you have to do that anyways. That part of the final assessment is just the same as normal. We're still going to be doing the topic map. And so yeah, I would start with the topic map and really look at all the topics that we did throughout the year and start thinking about how they're related to each other. What are the connections and that kind of thing. So yeah, I think that there is some really cool stuff that you can do with the project, and I'd love to help you out just to get you started, get those first steps going. Yeah, so are there any other questions before we jump into it, either on YouTube or on Discord? Doesn't sound like it. Okay. Yeah. So what I thought we'd do today is we take a look at this question from your book. I like this question because there's two ways of answering this question, and I mean, if you want, you can just look in your textbook and see the solution. I prefer that you kind of leave your book out of it for this time, because I don't want to spoil anything for you. So what I want to do today is I want to look at this question, and I'd like us to solve it in two different ways. One way is to use just trigonometry, the way that we would just go about it if I haven't told you anything new today. And then I'd like to introduce a new formula that we can use, and that formula makes this work much easier. So that's our goal for the day, is to solve this problem kind of like the hard way, like the brute force way, just using the common knowledge that we have right now, and then the kind of the more advanced way, like the grade 11 way. Okay, so let's just take a look at the question and kind of observe it and think about what we're asked to do. So we've got Pudluck's family and his friend. They own some cabins on the Cowlitz River in Nunavut. So it looks like this is their cabins here. So they wish to determine the distance from Pudluck's cabin to the store on the edge of town. Okay, Pudluck's cabin, store on the edge of town. Okay, yeah. So they know that the distance between their cabins is 1.8. Using transit, they eliminate the measures of the angles between their cabins and the communications tower near the store. So here's the communications tower near the store, okay, as shown in the diagram. Determine the distance from Pudluck's cabin to the store to the nearest tenth of a kilometer. So I guess what we're doing is we're assuming that this communications tower is pretty much the same distance away from Pudluck's cabin as the store, right? Because we're asked what's the distance between Pudluck's cabin to, well, the communications tower, or in other words, the store, because they say here that the communications store is near the store. So it's near enough that we're just going to calculate the distance between Pudluck's cabin and the communication tower. And what they're able to do is, Pudluck can kind of stay at their cabin, right, and measure the angle between his friend's cabin and the communications tower. So it's basically saying, okay, the communications tower is over there, your cabin is over there. What's this angle that I've made, right? So that's what they've done. And then Pudluck's friend did the same thing. So Pudluck's friend looked at Pudluck's cabin, and then the communications tower did the same thing, recorded 88 degrees. And they know that the distance between their cabins are 1.8 kilometers. Great. So what I'm going to do is I'm going to sort of copy this question out, or just the diagram rather, and then we're going to observe this question just as is. So this is 1.8 kilometers. I'm going to leave the units out of it for now. We know we're dealing with kilometers, so I'll leave that out for now. I'm going to say that this is the point A, this is the point B, this is the point C, and okay, that looks good. This is 61 degrees, and this is 88 degrees. Okay. So here's the thing. This is supposed to be a trigonometry question, right? And well, everyone knows trigonometry is all about right angle triangles. And well, it doesn't really look like this is a right angle triangle. Like maybe this is a right angle and this is just like a really bad drawing, but I doubt that. We can check, right? Because the sum of the angles in a triangle will always be 180 degrees, right? It's always going to be 180. So let's figure out what 61 plus 88 is. So 61 plus 88 is, what is that, 40 or 149, right? So 180 minus 149, that's equal to 31. So this is 31 degrees. Okay, so yeah, but there's no right angles in this triangle. So here's what we do. Here's the trick. Whenever you want a right angle triangle, just invent one. So boom, done. There's our right angle triangle. In fact, now we have two right angle triangles. Here's one, and here's another. Two right angle triangles. So now we can use trigonometry to calculate all sorts of things about this triangle. So basically what we've done is we've taken a triangle that's not a right angle triangle and we've turned it into right angle triangles. So we took something that we didn't know how to deal with and we turned it into something smaller, or we cut it up into smaller bits of things that we do know about. And that's a huge strategy that's used all the time in mathematics, is to take something really big that looks kind of overwhelming and to chop it up into smaller bits so that you can say, okay, well, I understand how this part works, and if I understand how all the smaller parts work, maybe I can put it back together. So that's what we're going to do. So we've got this right angle triangle, and now what I'm going to do is I'm going to draw both of these right angle triangles, and I'm going to draw everything that I know about them. So here's one of them. I'm going to call this side H because it corresponds to the height of the triangle. Okay, this is 61 degrees. This is 1.8. Okay, this over here, this also has H in it. And we know that this is 31 degrees. And that's really all we know. Okay, so keep in mind we did lose some information, right? We lost a little bit of information. We actually don't know right off the hop what this angle is here, and we don't know what this angle is here. But here's the thing, we can just figure it out. The whole point of, or not the whole point, but the whole concept of the sum of the angles having to total 180 degrees still works in these triangles, and both of these triangles have 90-degree angles. So this angle right here, this one that I'm pointing at right there, this is going to be, well, just the shorter way of doing this is just with by doing it directly. So 180 degrees minus 90 minus 61 is what, 29? So yeah, so this is 29 degrees. Okay. Yeah? Yeah. Okay, and then so this angle right over here, this next one, we can figure that one out, and that would be 180 minus 90 minus 31, which is going to be 59. So this is 59 degrees. 59 degrees. Okay, now I'm just going to say this. What we did, everything that we just did in blue, we didn't even have to do it. I just wanted to do it just to prove a point that even though like we lost a little bit of information, we were able to gain it back, right? So we actually don't need to know these angles. We did need to know this angle. Like this angle is important, but these angles here, not important. Anyway, okay, so what we're going to do now is, well, we're going to calculate H. So let's figure out what we would do. So this is going to be kind of our angle in question. Here's our angle in question. You might be. Oh, so let me just show you our game plan here. I guess I kind of jumped ahead. I just said, yeah, we're going to solve for H. Hold on a second. who's asking about h here? H is just some made up length that I made. Like we don't even know where it goes to. Well, here's the thing. We need to know this length here, right? And we're going to do this using right angle triangles. So what we're going to do is we're going to calculate this length here, and then we're going to calculate this length here, and then we're going to add them up. Okay? Yeah? Yes. Yeah, so we are going to calculate this, but I want to tell you why I'm calculating h. Like, why is h important here? Like, why did we bother? Well, let's take a look at this triangle. We know a lot about the angles of this triangle, right? We don't know any of the side lengths, which means that we're not going to be able to use any trigonometry on this triangle until we figure out what h is. So these are the sides that we're going to have to figure out. Let's figure out this side first. I think that's the side that people in Discord are wanting to solve for first. So we'll start off with this side. We'll figure out what that side is. Okay, and then, but that's not everything. We need to know what that side is. But in order to figure out what this side is, I need to know some other side length on this triangle. It doesn't matter which one, but I have to find some side length. So I could figure out what this one is if I figured out what this one was first, because it's the same h, right? So let's start off with this side then. Okay, so we'll start off with this side. So it looks like we have, well, I've got this angle here, and I'm going to calculate this side using this side. So this is showing me that I'm going to use the opposite side and the adjacent. Oh, sorry. Oh my gosh, I said h. Excuse me. I've got a lot on my mind right now. Okay, so we're looking for this. Yes, we're looking for this side length. Thank you. We've got this angle and we've got this hypotenuse. So we're going to use cosine because that is our adjacent side and our hypotenuse side. So AH is ka, so katoa, and so we would use cosine. So I've got that cosine of 61 degrees is equal to adjacent over hypotenuse. Let's call this side A, just because it's adjacent. So, oops, not D, A. A over H, and H I know is 1.8. Okay, hold up. I use the letter H here, so I'm being very sloppy. I use the letter H just to say hypotenuse, not this H, just to be very clear. I meant hypotenuse, not the height. Okay, so I've got A over 1.8, and so that means that A is equal to 1.8 times cosine of 61 degrees. So let's get our calculators out. So I'll punch in 1.8 times cosine of 61 degrees. Make sure that you're in the degree mode. And I'm getting 0.87. And I guess this is kilometers. Okay, great. So now we've got part of this. Now let's see if we can get the other part over here. But like I said before, we need to bridge some of this information from here to here. Okay, so let's go ahead and calculate H. So H is, well, let's see how I would go about that. It's pretty much going to be the same, except I'm going to use sine. So I've got the hypotenuse. I've got this angle. This is the opposite side. So OH, so katoa is sine. So I've got that sine of 61 degrees is equal to H over 1.8. So that means that H is equal to, and I think I'm probably covering this up with my head, H is equal to 1.8 times sine of 61 degrees, which is, okay, and to save time, I'm just going to, here's a nice little trick with a calculator. So I just use the arrow keys. I don't know if you can actually see this. I use the arrow keys to sort of navigate over the cosine, and then you can hit sine right here, boop, and then just hit equals, and then now it tells you the sine of that angle. So that's 1.57 something something something. So this is, I'll put that over here, 1.57. Okay, and that's kilometers. Okay, so so there you have it. There's the height. So that means that this over here is now 1.57 kilometers. So now I can use that information to get this side right here. Pretty neat, eh? So there's this side right here. So I've got this angle, I've got this adjacent side, and I've got the opposite side. OA, OA, TOA, tan. I'm going to use tan here. So let's see here. I'm going to call this side B. So I know that tan of 31 degrees is, well, opposite over adjacent. So 1.57 over B. Or in other words, I'll just make a little arrow. That means that B is equal to 1.57 over tan of 31 degrees. And I'm kind of running out of room here, so you'll have to excuse my squishiness here. So H is over there. There we go. All right, and so B is now equal to 1.57 divided by tan of 31 degrees equals. Okay, that is equal to 2.61. Yeah, 2.61. Let's call it 2.61. And that is kilometers. So I figured out what A is. I figured out what B is. So now I can figure out that A plus B is equal to, what is it, 1.57. No, that's H. A is, where is A? 0.87 plus 2.61, which is equal to, let me add those up. So 87 plus 0.61, 3.48, yeah. Awesome, and that is kilometers. So the distance is 3.48 kilometers. Awesome. Okay, so that's not so bad. Now, let's do the let's do the kind of the more elegant way, and what that's going to require is a little bit of information on. It's going to take a little bit of information about something called the sine law. In fact, it's not a little bit of information. I have to just tell you what the sine law is, and I might consider trying to prove it, but we are kind of in a bit of a time crunch, and the proof is really interesting, but I think it's something that we're going to have to sweep under the rug. But the moral of the story here is that this took up a lot of time, right? It's a lot of work. We had to split the problem up into two, and then solve two problems, and then stitch them back together, right? So yeah, this took some time, which is okay, but there's a faster way of doing this. So this leads us to something called the sine law, or the law of sines, whatever you want to call it. Let's call it law of sines. The law of sines. Okay. So the law of sines is basically gives us a formula to use the sine function to solve triangles that are not right angle triangles. So if a triangle ABC is not a right triangle, let me zoom in a little bit, it's not a right triangle, we can use the following formula to solve for all missing sides and angles, provided we have enough information. Information given, let's say. Okay, so that's the gist of the law of sines, is that it basically says, okay, trigonometry is great when you have a right angle triangle, but not all triangles are right angle triangles, so can we still use like sine, cos, and tan? Well, the law of sines says yes, you can use the sine function for triangles that are not right triangles. And you do so using the following formula. So just to be clear, I want to draw a little diagram here. Oops, I want it to look nice though. Oh, where'd my book go? There we go. Oopsies. Some Game Boy games fall off the shelf. So let's say that this is our triangle. There we go. You know, that actually looks like a right angle triangle. I want to make very clear that this is not a right angle triangle. So let me try that again. Okay, so here we go. Here's one. Here's one. This is definitely not a right angle triangle. Although it almost looks like an isosceles triangle, but it's not. This is just any old random triangle. We call this an oblique triangle. Which means no right angles. Okay, so this oblique triangle is just some random triangle, or I shouldn't say random, but it's arbitrary. This law still works for right angle triangles too. It just works for any triangle. So if this is the angle A, and this is the angle B, and this is the angle C, then we're going to call the opposite side of each side the lowercase of that letter. So B, A, and C would go over here, respectively. Okay, and let me just move this up a wee bit. Okay, so so this is what our triangle will look like, and the law of sines looks like this. Now, it's actually a very nice and symmetric formula, which makes it very easy to remember, which is really great. It is the following, that sine of A over A is equal to sine of B over B, which is equal to sine of, you guessed it, C over C. So there it is, and it's a super easy formula to remember. You just take each angle and take the sine of it and then divide it by the opposite side, and it doesn't matter which side of the triangle you do that to, you'll always get the same number back. And what this is really useful for is, well, I mean, this is not one equation, not two equations, but three separate equations, because the first one is also equal to the last one. So this gives you lots of opportunities to solve for these triangles, which is really great, because we want to be able to solve these. It gives us it makes us more powerful, right, to be able to solve these triangles. So so this is kind of like I always think of like learning a new formula, like in a video game, when you learn a new skill or something. It's like, oh, I'm more powerful now. I can use this for saving the world, that kind of thing. So this is the formula. Now let's go back and do this question again, and we'll see how easy this question is. Well, I mean, it's not easy, but how much easier and how much less work it takes using the law of sines. Okay, so I'll just go ahead and copy this. Can I copy this? Edit? I can't copy this? Whatever, I'll just paste it again. Okay, come on. There you go. And now I have to crop it and all that stuff. I did that ahead of time this time, so I wouldn't waste time cropping in class, but here we are. Okay, here we go. Crop, crop, crop. That looks good. And we've already seen the question, so I mean, it's not that important that we see it again. But here it is, nonetheless. So I'm just going to copy out the triangle here. Bada boom, bada bang, bada bing. 1.8. This is 88 degrees. This is 61 degrees, and that's all the information we have. Okay, so another parade, maybe. Okay, yeah, so I've got 61 degrees, 1.8 kilometers, another 88 degrees. So we want to know this side, right? So that's neat. So we know we want this side, we have this side. So why don't I start naming some of these things. So we already called this point A, this is point B, this is point C. So let's call this side A. No, sorry, not A. We'll call this side B because it's opposite to B, right? We will call the opposite of A, and this capital C here, the side is equal to 1.8. That much we know. So let's think about what we have and what we want. So the opposite side to, or the opposite angle to C, well, that we can easily solve for. We already did that in the last question. That is, what was it, 31 degrees? Yeah, it's 31 degrees. So we don't have to do that math all over again. 31 degrees. Okay. So yeah, let's go ahead and solve this. So I've got sine of 31 degrees over 1.8, right? Sine of this over this is equal to, well, I want this side, and I have this angle, so sine of 88 degrees all over B. And it's just an equation. It's got one variable. All of these other values, excuse me, all of these other values are just values, right? They're just numbers. So there's only one variable for us to solve for. So it's not like a system of equations or something where there's all sorts of variables that we have to juggle with. No, it's just the one variable. We just have to solve for it. So I'll show you a quick trick. So if I have A over B, and that's equal to C over D, provided that B is not equal to 0, and D is not equal to 0, or I guess none of these are equal to 0, so A, B, C, or D are non-zero. So provided none of these things are 0, we get that B over A is equal to D over C. It's just a fact. Okay. You could fiddle around with algebra and you'll find this fact before long. And so we'll use this fact just to make our lives a little bit easier. So basically the idea is that if you have an equation that has like numerators and denominators, you can flip them upside down and nothing about the equation changes. It's the same equation, just the algebra might be a little bit easier to deal with. We're going to do that because our variable is in the denominator. If you wanted to, you could fiddle around with cross multiplication and that would be fine, but I'm just going to go straight to the point. I'm going to say that 1.8 over sine of 31 degrees is equal to B over sine of 88 degrees, and 88 degrees, that's close enough to an 80 degrees, okay. And yeah, the reason I'm going to do that is because now my B is in the numerator, and I don't have to worry about bringing it up into the numerator, okay. So let's start calculating some of these values. I'm just going to do this. So 1.8 over sine of 31, see here, so I've got 1.8 divided by sine of 31, that's equal to 3.49. So, 3.49, and that's equal to B over sine of 88. Well, sine of 88 is equal to 0.99, or I'll call that 1.0 because I'll round to the nearest hundredth, and so that's 1.00. So basically B over 1 is just 1, so B is equal to 3.49. And is that what we got last time? I think it is, isn't it? We got 3.48, but close enough, right? Yeah, and that just comes from a rounding error, right? So that's why rounding numbers is not a precise way of doing things, and that's why we should actually be putting these little dots over our equal sign, because these actually, I mean, those are equal, but over here we're kind of, as soon as you start rounding, you start having some imprecision, right? So even though our we're still rounding to the same decimal place, right? We're still rounding to the nearest hundredth. Because we're doing it at different times, our order of operations are now different. So then we may be introducing a number that's just slightly bigger earlier on, so that error becomes bigger later on in the problem. So something that you learn in a first year physics class at university is something called significant figures. You may learn it in some science classes in high school as well. I think chemistry deals with it as well. But the idea of significant figures is saying, okay, well, let's say you want to round to the nearest hundredth, and you want to do so properly. Like how precise do your calculations have to be ahead of time before you do that final rounding? So significant figures are important, but I'm not too worried about them. To me, this is close enough. 3.48, 3.49. Like in the grand scheme of things, that's 10 meters in this question, right? So 10, and already we're talking about how close is this thing to the store, and we're already kind of talking about a communication tower that is near the store, right? Like if we look at the question. So the difference of 10 meters, I don't think is that big a deal, but maybe it is. I don't know. Okay, so that's the law of sines. We're gonna end it there. So just thinking about what we can do for an exit slip today. I'm gonna hold off on homework for today, so no homework today. There's still some stuff on the sine law that we need to talk about. In particular, the ambiguous case. Okay, so that's what we have to talk about tomorrow, and then next week we'll talk about the law of cosines, and then we're getting like really close to being finished all this material. So kind of crazy that we're here, but yeah. Anyways, we'll talk to you guys tomorrow. Again, I'm really sorry about the final exam mix-up. I really don't enjoy telling people that they can do things and then later having to tell them that they can't do that anymore. It's not my favorite thing to do. So yeah, I'm gonna sign out now. Wish me luck with my computer. Maybe the start button will start. But I've been trying to use Linux. I think I may have mentioned that earlier, that I made the switch to Linux, and it couldn't have been at a better time. Yeah, so I am gonna go. I'll talk to you guys tomorrow. Bye bye. Okay, dokes. How do I get out of here? Hold on a second. Okay, stop streaming. Yes.